Hello everybody, this is Mr. Mac. I'm going to do problem 2, which is like problem 1b. This is from the year 2001-2002. I've already put the givens in. 46.15 for this side EF. GFE, the angle is this big angle right here. And then I really need to do the other given. 43, 34, 24. Let's make sure I'm putting that on the right side. 43 degrees, 34, 24 seconds. All right, first thing I'm going to do is I'm going to solve for this angle right here. Because we have triangle adding up to 180, I'm going to go ahead and use that. This example, I'm going to arrow up and find my solutions instead of storing variables, which is one way you can do it. You can store variables for accuracy. You can write out a bunch of digits for accuracy, or if you have a TI-84 or above, you can arrow up, and just by simply hitting enter, you can grab whatever number you want, which is the method I will be using today. So I'm going to go ahead and put in 120 degrees, 20-second angle 2, and then 18, it's going to be alpha plus, where the double quote, the seconds, is hiding above the plus. It's kind of crazy, but there it is, sitting right there now. And I'm also going to put in 43 degrees, 34 minutes, and look at what I did. All right, I'm going to go back. Angle, put the degrees in there instead. For 34 minutes I need. 34 minutes. Number 2. I'm just going to hold this here. And I'm going to get a little glare there. I'll try to do this instead. Okay. And 24 alpha plus seconds. Okay, so there's that. Now, when I'm doing this, I want to make sure that I just go 180 minus, I can go up and grab that one. I said we could subtract the other one as well. And now I know that this angle right here is 16.08. 16.088 degrees. Now that is not one of the things, is that one of the things I'm looking for? Yes, I'm gonna go second angle 4, which is converting into DMS, and I got 16.518, which is the first thing they need. So I'm gonna go ahead and go 16 degrees, 5 minutes, 18 seconds, and there's my first 6 points. Okay, back here. Since I have this whole entire triangle, I'm going to try solving some different things. It seems to me, because I have this left-hand right triangle, that I already know, thinking about a right triangle, if I know this, the hypotenuse, and I know this angle right here, I could just use either law of sines or right triangle trig, SOHCAHTOA. Right triangle trig. Sine of A over A equals sine of B over B, or of course sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse, and tangent is the opposite over adjacent. SOHCAHTOA. All right, I'm gonna do that. So let's go. The sine of E is FH over 46.15. I know this. This is opposite over hypotenuse. I'm just gonna go 46.15 times the sine of E. And E, of course, is the number that I had stored way up here. So if I just multiply both sides, 46.15 times the sine of E, FH is going to be 46.15 times the sine of E. I'll write that. So I'm going to go ahead with my calculator and go 46.15 times the sine of. Now I got to go up and find that 43 degrees thing, and hopefully this video will be helpful. You can go back and pause and whatever parts you want that you need, making sure I'm in degree mode, of course, which is important. And now this is 31.81. Now I'm going to check my answers. Yes, that's right. So this, I'm going to put in quotes, 31.81, because it's rounded, but that's rounded to the nearest hundredths, 31.81. And now I've got this right here, 31.81. I'm almost there. Now, seeing as I need EH, I still need EH, put a dot right there. I still need FG, I'll put a dot right there. And I still need GH, which is this bottom one. But I've really just got two right triangles I need to solve now. So I could just do Pythagorean theorem. Okay, so I'm showing first right triangle trig, SOHCAHTOA. I'm going to use Pythagorean theorem, but then over here I'm going to use the law of sines, so you can see that I can use any of these different methods. But the nice thing about the Pythagorean theorem is I'm just going to go square root of this squared minus this squared equals this squared, because we know, and I'll write it right here, that EH squared plus 31.81 in quotes squared, those aren't seconds, those are quotes, equals 46.15 squared. But I'm going to let my calculator do the work. So I'm going to go square root of 46.15 squared minus, now notice this 31.81 is something I use, so I'm going to go up and grab it. That squared, square root of, oh nuts, I forgot to square root it, or I forgot to square it, so I'm going to go back. Second enter brings back up what you did, arrow back in. I'm going to hit squared, and now I've got my 33.43, which rounds to 33.44. And that is what this guy right here is going to be, 33.44 in quotes, because I'm rounding. But because I need to round, I've got 33.44, and there is 3 of my 5. Onward. Okay, now I'm going to find, let's do law of sines. So if I go sine of 16.088 over 31.81, it'll equal, oh, you know what I was thinking? I could actually find this angle up here, subtract it from this angle to get this one here. A little bit more exciting than just using right triangle trig again. That's kind of a cool thing. So let me show you what I mean. If I go 180 minus 90 minus this 43 one, 180 minus 90 minus, I'm going to go find that 43, 34, 24. Where is that? 40. Oh, there it is. That's my angle. So if I subtract all of those, and then you could do degrees, minutes, seconds, of course, or you can just go that 120 degree one minus that. I go all the way up. There it is. And I subtract. And I'm going to show you another feature of the calculator. Remember, right above the answer button, right above this negative button is the answer button. So I'm going to go second answer. Boom. That is what this angle right there is. I'm going to go ahead and just point at this part and say, hey, that is 73.911 degrees. Now, interestingly enough, it's kind of fun now to do law of sines, especially because I have this. I'm going to try to be as accurate as possible. And the sine of 73.911 over GH, which I need, should equal the sine of 16.088. I'm not going to round any of these, over 31.81. Now my givens, I need to keep track. Where's that? So I don't need to round that, or I don't need to worry about unrounding. Was also that, and my other one was this angle in the corner. Anytime I use those three, I don't need to worry about how I've rounded. Okay, so now I'm just going to do the law of sines here, and I'm just going to go, remember when you're doing the law of sines, it's going to be this times this divided by this. GH times that equals 31.81 times that. But really, in essence, it ends up being these two multiplied together divided by that. So I'm going to let the calculator do the work again. So I'm going to go sine of, now I got to have that 73.911 multiplied by 31.81, shoot. 31, oh nuts, I lost it all. Here, let's try it again. Sine of 73.911, close it, times. Now I gotta go find that 31.81, I know it's up, there it is, enter. Divided by the sine of 16.088, which I think was way up. And of course you can, oh, look at that. There it is in DMS or there. I'm just going to grab that one. If you don't like arrowing up, if you don't have the ability to do that or store variables, you can just write out a bunch of digits and it should be fine. A bunch of digits, so you want to be accurate. Close that. And there is my 110.29, which is exactly what we want. Just realized this video is going to be sideways. Sorry about that, everybody. So I've got 110.29 110.29, which is going to go down here for GH, 110.29. And last but not least is my hypotenuse, which I'll do good old Pythagorean theorem. So I'm going to go 31.81 squared plus 110.29 squared equals c squared, or fg squared. And I'm going to let my calculator do the work again. Square root of 31.81, which I'm going to go hunting for. There it is. Squared plus this 110.29, which is brand new, squared, enter, 114.79, 114.79. Let's make that look like it's together. 114.79, and these are all accurate to the nearest whatever they asked for. And as you notice, the actual grading rubric for this question, there are my solutions right there, my answers. There are my answers. They all match to the nearest hundredths or the nearest second. And that is how you do a problem 2 or problem 1B. And every year is pretty much the exact same type of question. And I hope you learned something about how to solve that problem. Thank you.